phase relationship of sinusoidal waveform. Leading or lagging. Okay. All right. So, for example, this is a reference voltage, right? Okay. V sub m sine omega t plus 0, right? Okay. And omega t is the alpha here. Starting point is going to 0, but like this one, shift the go to the left, minus, right? Minus. For example, minus the 30. So what is the formula here? V sub 1, for example, V sub m sine omega t plus 30. Okay. So because the omega t plus 30, alpha plus 30 is going to 0, minus 30. So shift to go to the left. This is the leading. So the leading, very important. Okay. Let's say leading, the formula is A sub m sine omega t plus theta. Go to chapter 1, page 19. Okay. So the other one is for, let's say, this is the reference. Okay, please a reference. Same thing, V sub n sine omega t plus 0. Okay, because the starting point is going to 0. So that one here, like this one, the alive later than the reference voltage, the ending point, the period. So that would shift the go to the right. Okay, for example, this is the 30-degree here. So that was the omega t plus minus 30-degree, 0, omega t 30. So for this case, the lagging A sub m sine omega t minus theta, because it's going to the 0, like this one here, omega t theta, the plus the theta. Okay. So to make the plus by theta, to be generating the lagging, that was for the general format is AM times sine omega t minus theta, that is the lagging. But here, so AM times sine of omega t plus theta, okay? All right. And then the other thing here, okay. So I'm gonna just really quickly go over for the let's say the impedance with phase relationship. Okay, so the impedance mean, the three, the response from the three basic elements R, L, C. Okay, R, X sub R, G sub R here. Okay. L, X sub L, 2 pi F L, and G sub L, X sub L, 90, X sub L, J. And C is what? C is the X of C, 1 over 2 pi FC. And that is a G sub C, X sub C, minus 90 degree here, minus J, and X sub C. Okay. So, let's see, it's like the K's, the R, like this one. For example, that is the V of T. And like this one. That is I of T. So for R case, V of T are in phase with I of T. Okay. And let's say this is L, the inductor case. Okay, inductor case, V of T. And sorry about that. This is V of T is leading I of T, okay, by, okay, oh, not by here. This is the pure case. So for the inductor case, V of T is the leading by I of T, okay? So usually pure cases, that is the 90 degrees. So what that means, I of T is lagging by V of T by 90 degrees, okay? By 90 degrees. Yeah. So last one is C, the capacitor, the cases. This one here. That was for what? I of T. And let's see. That was the V of T. Okay. So for this case, for the capacitor case, I is leading V of T by 9 degrees. This means V of T is what? Lagging IC of T by 90 degrees. Okay. For the capacitor cases. So for the lab 7, you have to know about the two concepts, okay? It depends on the three different the basic elements that was the leading or lagging between the phase relationship, voltage and current. And also you have to know about the how can you find X sub L, X sub C, G sub L, and the G sub C. And then from the two sinusoidal waveform, you can find the phase, the plus sometime, or sometime the minus. It depends, okay? So please go back to the reminder of you, the chapter 1, okay? The page, the 32 to 35. and also the 19 to the 23, okay? All right, so now I have, so really the basic one here, okay? For the lab 7, you see some L sub 1, okay? R 4.7 millihenry. R is 220 ohm here, and R sub 2, what? 470 ohm here, and C sub 1 is what? 100 nanofarad. And V sub S, the source voltage, is 4, the peak voltage, and 0. And then the frequency is 1 kilo the hertz, 1 kilohertz, okay? 1 kilohertz. All right, so now we need to looking for what is the V sub L and what is the setup L, mean it's like the amplitude, the setup, okay? And then what is the capacitor voltage and capacitor the setup? So that was V sub C, zeta C. So we tried to multisim and also the breadboard in the real case, but now I'm gonna using the showing you for the solutions by the hands, okay? All right, so the first of all, you have to know about the concept voltage divider rule, okay? So you can go back to the chapter 2, okay? The voltage divider rule here. So for example, let's say the G sub R. Oops, I'm sorry. For example, G sub C, okay? That was, for example, full voltage. So V sub G sub C is what? G sub R plus G sub C over G sub C multiply full volt. Okay, V sub G sub R is what? So G sub R plus G sub C is G sub R multiply full volt. So the full voltage is V sub G sub R plus V sub G sub C. Okay. So now we go back to the real number. So for this case, for in the two parallel circuit, we apply to for voltage. Why? Because they are in the parallel. They are in the parallel, right? So now to find the question 1, we sub n and set up sub L. So G sub R sub 1 is 220 ohm, okay, 0. And then G sub L sub 1 is what? X sub L sub 1, 90. What is the X sub L sub 1? 2 pi F L sub 1. 2 pi 1000 hertz multiply 4.7 millihenry. So I'm gonna using the calculator. Okay. Later, so 2 multiply pi multiply 1000 multiply 4.7 multiply 10 to minus 3 because it is the millihenry. Let's say 29.5, okay, to 29.5 here. All right. So for this case, okay. Oops, I'm sorry. Like this one. 29.5, 90. Okay. So go back to the here. V sub L sub 1 is 1. G sub R sub 1 plus G sub L sub 1 is like G sub L sub 1, both divide rule here. So G sub L sub 1, 29.5, 90. And G sub R sub 1, like this one. And then that was also 29 point J, like this one. And so 29.5 J. So the after the calculations, let's say, all right, so pull to 0, shift to 9.5. All right, so now 221.9, 7.6, 29.5, 90 here. Okay. So for this case, the 29.5 divided 221.9, zero point what 133 and 82.4 degrees. Okay, so here that was what that was. I'm writing for you more bigger one. Okay, maybe okay color. Right, that was what V sub L theta L. So that is the answer. Okay, the answer what here I'm gonna share with you like this one. Oops, like this one. Okay, so that should be the plus. Okay. Okay. The question two. Okay. The question two. Question two. Here. Same approach. Question two. More faster. Yeah. Question two. So G sub C1 over G sub C1 plus G sub R multiply 4 V sub peak because that was what V sub S. So G sub C sub 1 is what? G sub C sub 1 is equal to X sub C sub 1 minus 90 degree. X sub C sub 1 is 1 over 2 pi FC minus 90 degree. 1 over 2 pi 1000 multiply what? C is what? C is for 100 nanofarad. 100 nanofarad. Okay, minus the 90 degree here. So the after calculation of 1, 2 times pi times 1000 times, okay. So that would 5, 1 over 2 pi multiplied into minus 4. So I think that was 1 over 2 times pi multiply 10 to minus 4. All right, so that was 90 degree here. 1591 point maybe 6 minus 90 degrees. So the G sub 1 like this one. Okay. Oops. All right. All right. So, oops. Okay. So the G sub 1 is 1,591. Okay. The 0.6 minus 9 degree. 1591.6 minus 9 degree plus what? 470. Okay. Multiply 4. That was what? B sub C, zeta C. So, all right. So we are make a formula. Okay. Let's say pole 470 shift minus 1,591.6. Okay. Minus 73 degree here. Or so that was maybe minus 17 degree. Okay. Minus 17 degree and amplitude multiply 1591.6 divided 1659.5. Okay, that was 3.84. Okay, so that is what is for here. Second one. Okay, here. That was, oops, I'm gonna pull one. Okay, let's see, so 1, so 1. Okay, that is the answer. Okay, thank you.